So let's look at the first problem. So you have a block sliding down an incline that is at 25 degrees. Anyone needs the worksheet? Do you have worksheet? You just came in, right? Okay. So first thing is you need to draw the diagram for the problem. So draw an inclined surface. So we have the surface, and then we have this inclined surface. So let's see if I can draw a straight line. So draw inclined surface at 25 degrees, about 25 degrees. Okay, so let's say that's 25 degrees. And then draw a block. So that block has a mass of 75 kilograms, and in the previous problems we neglected the friction, but now we have friction which coefficient is given by 0.3. Okay, so we talked about two types of friction last time. One is static friction. So the maximum static friction before the object slides is given by coefficient of friction, static friction times normal force. Okay, this is for the static friction when the object is not moving. And if it is already moving, then we have kinetic friction, and kinetic friction is given by mu k n. Okay, so the only difference is in this case the coefficient is static coefficient, and in this case the coefficient is kinetic coefficient. So you need to decide whether the object is not moving or not, and then you need to choose either this one or this one. So that in this problem the block is already sliding down. That means we need to use this one. Okay, so it's sliding down. That means the friction would be in the opposite direction. So friction is always in the direction opposite to the direction of motion. If it is moving down, then the friction is up. So I will draw friction in the upward direction. So that's the friction, and it's F sub k. Okay, so now draw all the diagrams, all the forces that are acting on the object. So we have what forces? We have weight, which is vertical down. So draw the weight arrow. So that's the weight. Okay, and then there is normal force, which is perpendicular to the surface. So draw that. So that's the normal force. And then what else? Yeah, so those are the only forces we have. And then I also need to write x and y coordinates. So I will just write the x and y coordinate on the same figure, or you can write it separately also if you want. So this would be my y coordinate, and x coordinate would be along the surface. So draw that. So that's my x coordinate. Okay, so this is positive x, and this is negative y, and up is positive y, and this force is normal force. This is weight W, So we have three forces acting on the object. So the first question is draw the free body diagram, which we already drew. The next one is write the equations summing the forces in x and y directions. So we want to write all the forces and then add the x forces and add the y forces. Okay, so this is 25 degrees, and we showed last time in the lab that this angle would be same as this angle, so these two angles would be equal, so this would be 25 degrees as well. So sum of all the forces along x direction. So this normal force doesn't have any x component, so there is no x force for the normal force. Fk is all along x direction, so F sub k oh, did I draw? Okay, yeah, okay. So then F sub k is positive because it's along positive direction, and we have weight. So this weight has both x and y component, so let me use different color for that. Let's use this one. So for x component, it would be W sine 25. It's away from the angle, so that's sine. And this x component of the weight would be W cosine 25. Okay, so we are talking about the x component. So add this one, and I'm writing negative sign here because it's pointing to the negative x direction. So that's negative x direction. So weight sine 25 degrees. Okay, that's the sum. And according to Newton's second law, sum of the forces is always equal to mass times acceleration. Okay, so that is equal to mass times acceleration. And which way the object is moving? The object is moving along the negative x direction, so that means we need to put minus a here. Okay, so when the object moves along x direction or negative x direction, we need to put minus for the acceleration because acceleration is pointing down. So that's for x direction. For y direction, sum of the forces is normal force, which is pointing up, so positive, and then Fk doesn't have y component, it's all along x direction, and then weight has this component, which is W cosine 25 degrees, so it's along negative y direction, so put minus sign there, is equal to mass times acceleration in y direction, but there is no acceleration in y direction. The object is not accelerating up or down, so that means acceleration is 0, okay, or mass times acceleration is 0. So those are the two equations. And next part is what is the acceleration down the incline. So this equation won't give us the acceleration, so that means we need to use the first one. So start with the first one for part C. This is part B, this is part A. So F sub k, we know F sub k is given by that, so mu k n minus W. W is mass times acceleration due to gravity, m times g, so m times g cosine, sorry, not cosine, sine 25 degrees is equal to negative mass times acceleration. Okay, and we don't know n, but we can use this equation to get the expression for n. Okay, so from this one we can write, let's see what someone is asking question here, so let's see what the question is. Where did you get mg? Okay, so mg, this W is weight, and the formula for weight is mass times acceleration due to gravity. Okay, that's something that we talked in the previous lecture also. So whenever you have a weight you can write that as m times g. That's always true. Okay, so again we don't have normal force, so that means we need to use this equation to replace the normal force by something that is known. So using this we can write N is equal to W cosine 25 degrees, and again W is m times g, okay, from here. So cosine 25 degrees, and we can use this N in this expression. Okay, so use this in the above expression. So mu k N is mg cosine 25 degrees minus, we have mg again sine 25 degrees is equal to ma, minus ma. Okay, so in this equation all the terms have m, so we have m here, m here, m here, so we can cancel all the m's. When they are common we can cancel the variable. Okay, so mu k g cosine 25 degrees minus g sine 25 degrees is minus m, m is gone, so a. So we want to find a, so write expression for a would be, so in order to get rid of negative sign here, so you can multiply both sides by negative sign or -1, so then it would be a is equal to so this would be, if you multiply all the terms by negative sign, this would be negative and this would be positive. Okay, so the sign changes. And then we have g common, so you can take g outside the parenthesis, so this would be positive, so sine 25 degrees, I took g outside the parenthesis, and then this would be negative because we are multiplying by negative, so that's minus mu k, g is already outside the parenthesis, cosine 25 degrees. Okay, so then you plug in the values, so g is 9.8 meters per second squared, sine 25, mu k is given in the question, it says the coefficient of friction is 0.3, okay, and then cosine 25 degrees, and then you do the calculation. So see what you get. Is that 1.48 meters per second squared? So I have 1.48 meters per second squared. Okay, that's good. And acceleration is a vector, so you want to write it as a vector, so use this arrow sign over it, and you need to specify the direction. Okay, so this is the value, and the direction is, which way is the direction? It's along negative x-axis, so you need to say it's along minus I hat. Okay, so this tells us that it's along negative x-axis. So that's part C. Now let's look at part D. So part D is using the kinematics. You guys have already done this kind of problem before. So we have this acceleration, and the block starts from rest, that means velocity initial is 0, and time is given 2 seconds. Okay, acceleration is 1.48, and it's asking to find its final velocity after 2 seconds. So tell me which equation should I use here. So we have 3 equations. First one is this one, a is equal to v final minus v initial over t. Can I use that one? This one? A is known, Vi is known, T is known, so we can find Vf. Okay, so we can rearrange this equation to write in terms of Vf. So rearranging this, we get Vf is equal to Vi plus At. Vi is 0, A is 1.48, and T is 2 seconds. So that gives us 2.96 meters per second. And again, velocity is a vector quantity, so if you want to express both the direction and magnitude, you can write this as 2.96 meters per second. And which way it is moving? It's moving along negative x. It's moving down, so minus I hat. The last one is how far down the block has it traveled? So we want to find delta x displacement. So which formula should I use? I can use delta x is equal to VIT plus 1/2 AT squared, or the second one also is fine. So VIT is 0, velocity is 0 initially, 1/2 acceleration is 1.48, time 2 seconds, square of that gives me 2.96 meters. Okay, and displacement is also a vector quantity, so we can write this in terms of vector. So 2.96 meters, it's along negative x direction, or I hat. Okay, so that's number 1. So number 2 is a similar kind of problem. So I want you guys to start number 2. It will give you a good practice on how to use friction in the problem. Okay. So the first thing is draw an inclined surface. Not inclined surface, sorry, it's a flat surface. Okay, so draw a flat surface. So start with the flat surface. So we have this surface, and there is a crate on the surface. Okay, and then you're sliding the crate across the floor by pulling it on a rope, and the rope is at 40 degrees to the floor. So that means you're applying the force at 40 degrees. So this angle is 40 degrees, or you can define the coordinates here. So you can define this as x coordinate and this as y coordinate. Oops. So this one is 40 degrees. Now you need to write all the forces. The force that you are applying is through a rope. That means you are applying tension. So there is tension force. There is weight force, which is vertically down. There is normal force because it's on the surface, so normal force is vertically up. And then there is friction. Now you need to decide whether it's a static friction or kinetic friction. So the block is, the crate is sliding on the surface, that means it's kinetic friction. So friction is on the opposite side of the force or opposite side of the motion. So this is the friction, F sub k. So those are the forces we have. So the first question is asking, what's the acceleration of the crate? So the box starts at rest. So initial velocity is 0, and it travels 12 meters in 4 seconds. So this is a kinematics problem. So you need to decide which formula you want to use out of those 3 kinematics equations. So we have this formula, delta x is equal to VIT plus 1/2 AT squared. Delta x is 12. VIT is 0. 1/2 A is unknown. T squared is 4 seconds squared. So you can do this math. So 2 times 12 is 24. Just multiplying both sides by 2. A times 4 squared. And then A is 24 over 4 times 4 squared is 16. So 24 over 16. That is 1.5. So the acceleration is 1.5 meters per second squared, and it's along positive x. So that's I hat. Okay. So this means again along positive x. Part A is that. Part B is draw the free body diagram, which we already have drawn here. The third one is write equations summing the forces in x, y, and y direction. So why don't you guys write that? So just like before, sum all the forces along x direction and sum all the forces along y direction. If you want, you can make table to show all the forces, but that's not necessary if it is clear what forces we have. So we have friction force along x direction, and it's negative because it's pointing to the left. What else we have along x direction? Tension, a part of a tension, not the whole tension, but this x component of the tension, which is T cosine 40 degrees. Okay, so this tension has T cosine 40 degrees along x direction and T sine 40 degrees along y direction. So those are the two forces along x direction, and it's moving. So Newton's law tells us force is ma. So m, in this case, A is positive because it's moving along positive direction. So just A. For y, we have normal force pointing up, weight pointing down, and a part of this tension, which is T sine 40 degrees. Mass times acceleration. It's not accelerating up or down, so it's 0. So these are the forces we have for x and y directions. What's the magnitude of the tension? So we want to find tension. So you can use one of the equations. both equations have tension. So which equation you want to use? Depending on what's given, so you can use either the first one or second one. So let's start with the first one. So Fk, I already gave you the formula for Fk. Fk is mu k times n. So you can start with this one, mu k times n minus plus t cosine 40 degrees is equal to ma. Okay, in order to find t, we need m and a. So I think we have m and a given, no problem. We have mu k, so that's fine, but we don't have n. So n is not given. That means somehow we need to eliminate eliminate n. So to do that, we can use this equation. Okay, so let's call this equation 1, equation 2. Use equation 2 to eliminate n in equation 3. So express this equation in terms of n. So n is equal to w minus sine 40 degrees. Okay, so what I did here is I have this equation, so took this whole thing to the right, okay, and change the sign. So you got that, and then w is, we know it's mg, always true. So mg minus t sine 40 degrees. Okay, so let's call that equation 4. Now you substitute this n in this equation. So that's how we can eliminate n, because we don't have n. Okay, so substitute equation 4 in equation 3. So minus mu k, so replace this n with w minus t, or mg minus t sine 40. That's n, and then we have plus t cosine 40 is equal to ma. Okay, now in this equation everything is known except t, so you need to express this in terms of t. So I want you guys to do that. Okay, so put all the quantities on right side and t on left side. So how do you do that? Take this whole thing to the right, so this negative becomes positive when you do that. Okay, so t cosine 40 degrees is equal to ma minus mu k no, I cannot do that because we have t here, so we need to separate the terms with and without t. Okay, I thought like there is no t here, so again we are putting t on one side and everything else on other side, so that means separate the terms with and without t first. So let's separate this. So mu k mg, okay, so that's the first term, and then minus and minus would be plus, so mu k t sine 40 degrees plus t cosine 40 degrees is equal to ma. Okay, now this is without t, so you can take this to the right. So these two are with the t's, so take the t common. Okay, so I'm taking this to the right here. So for the left, the terms on the left, we have t mu k sine 40. So t is out of the parenthesis, so we have plus cosine 40. On the right I have ma, and I'm also transferring this to the right, so it's plus mu k mg. Okay. So does that make sense? If you guys are not sure what I'm doing, so let me, ask me the question. Okay. So let me just review here. So this is, I'm substituting this thing for n. Okay, this is n. Everything else is same. This is equation 3. This thing is n. And then I'm distributing this mu to these two terms. Okay, mu mg, and then mu times t sine 40 degrees. Okay, that's that. And then everything else is same. And then this is without t, so I can take it to the right. So ma times mu k mg. And on the left we have these two terms, and on these two terms we have t common, so pull t out of the parenthesis, and then everything inside the parenthesis. So we have mu k sine 40 degrees, and here cosine 40 degrees. Now t is equal to, divide both sides by this whole term. Okay, if you do that, then this term would be cancelled, and then on the right side we'll have mg or ma mu k mg over dividing this by this term, so mu k sine 40 degrees plus cosine 40 degrees. Okay. Now everything on the right side is known, the values are given, so you can plug in the values. Mass 80 kilogram. We found acceleration in the first part, which is (1.5). Mu k is given, which is 0.5. By the way, this mu coefficient of static and kinetic friction, these are unitless. Okay, there is no unit. And mass 80 kilogram, g is 9.8 meters per second squared over mu 0.5 sine 40 degrees plus cosine 40 degrees. Okay, so enter all these numbers on your calculator, and that will give you the tension, which would be 471 Newton. So now I want you guys to do number 3. This is number 3 is similar to this one. So start the problem with a diagram, and then draw free body diagram, and do all the things exactly same as what I did for number 2. So I think you guys can do number 3. It's pretty straightforward, so I will just skip this one. If you cannot do that, you can ask me next time, and I will show you in the next class. But let's look at number 4. Okay. So for number 4, draw the free body diagrams for both the hanging mass and the mass on the table. So the problem is, here we have a table, and on the edge of the table we have a pulley, and there is a mass or a box sitting on the table, and the box is connected to a rope that passes through the pulley, and on the other side of this rope there is a mass hanging. Okay. So call this mass MA and call this one MB. So there are two objects here, so you can draw two free body diagrams for each of the masses. For each mass we can draw one free body diagram. So start with the hanging mass. So hanging mass has weight vertically down, which is W. So rather than writing W, I will just write mg. It will be easier. So m times g. Okay, so that's the weight of the hanging mass. And then there is also this force exerted by the rope, which is tension. Whenever you have a rope, that means there is a tension. Okay, so that's T. So that's for this mass. And on this free body diagram, you can also show which way is the acceleration. So which way the object is accelerating. So the object is sliding down, that means the acceleration is down that way. Okay, so that's the acceleration. Now when you do this kind of problem, sometimes you may make mistakes with signs. Okay, there is a chance that you may mess up the sign. So in order to use the signs correctly, my recommendation here would be always choose, okay, this is always true. You don't have to do this, but let me just recommend this to keep track of all the signs. So choose the coordinate, or I should say positive coordinate, along the direction of. If you do this, then you don't have to worry about the signs, okay, signs of acceleration, making mistakes with the signs. So choose the positive coordinate along the direction of acceleration. So in this case, acceleration is down. So instead of choosing up as positive, we will choose down as positive y-axis. Okay? Then you won't get wrong signs if you do that. Okay? You don't have to do this if you take care of all the signs, but then if you do this, then you don't have to worry about making mistakes. So this is for hanging object. Now for the object on the table, so let's write all the forces. There is this tension, and this tension would be same, okay, because they are connected to the same rope. So that's why I'm writing the same T. And then is there friction? So let's see. Yes, there is friction. So friction is always in the opposite direction. And in this case, the block is moving, so it's F sub k, kinetic friction, not static friction. What else we have? We have weight of the block. In this case, weight is m, a, mass is a, and acceleration due to gravity. And there is also normal force because it's on the surface, so n. Okay, so that's the free body diagram. And here in this case, it's accelerating this way, so we'll choose this as positive x and up as positive y. Okay, so Then you can start with the addition of the forces. Here for this block A, you can write sum of forces along x direction as negative Fk, it's along negative direction, and then T along positive direction. Okay, that is equal to Newton's second law is F is equal to ma. So m times a, it's along x direction, so I want to write x here, and along y direction the sum of forces is n minus weight. Okay, so that's the forces along y direction, and for y direction there is no acceleration. The object is not, for this one, the object is not moving up or down or accelerating up or down, so this is 0. Okay, so for block B, we don't have x forces for block B, there are only y forces, and we have tension. Is it positive or negative tension? Should I write positive or negative here? Negative, because we are choosing up to be negative here, okay, using this convention, and then down to be positive, so that plus mbg is equal to m, it's accelerating down, so ma. Okay, so because there is no acceleration here, I will just write just write a here, okay, because we only have one acceleration, so we don't need to differentiate the direction for the acceleration. So we have these three equations, and out of the three equations we want to find a, and because these two blocks are connected by the string or by the rope, so acceleration for this one and acceleration for this one would be same, because they would be moving together, so same acceleration. So this one and this one would be same, and the tension for the two blocks are also same because they are connected. Okay, so the thing is that we want to solve these three equations to get a. So how we do that? So you can start with any equation. So start with this one. Okay, so you can write this as n is equal to m a g. Okay, so let's call that equation 1, and then now we don't have tension, so we want to get rid of tension between these two equations. So get rid of tension between the two equations. How do we do that? So write this expression in terms of tension. So you can write this as so take this tension on the right side and this MA on the left side, we get T is equal to MBG. Oh, by the way, this is also MB because we are talking here about block B, so this is MB, and here we are talking about block A, so this mass is MA. Okay, so let me write this capital. So MBG minus MBA. Okay, so I wrote this whole equation in terms of T, and the reason I'm doing this is to get rid of T between these two equations because we don't have T. Okay, so plug this T in this expression and we get what? Mu Fk is minus mu Kn. Okay, that's the formula for Fk, plus T, replace the T by this Mbg minus Mba, and on the right side we have this thing which is MAA. Okay, so our purpose here is to get A, so put all the terms with A on one side and everything else on other side. So take this to the right so that we have A on one side. So minus mu normal force, we don't have normal force, but we have this expression, so use that here. So MAG plus MBG is equal to MA. When you take this thing to the right, it becomes minus becomes plus. Okay, so we can write this as A is common, so pull it out of the parenthesis, MA plus MB times A, just taking the common term out of the parenthesis. And here we have G common, so you can pull G out of the parenthesis. So mu K here, mu K MA plus MB and G outside the parenthesis. Okay. So to get A, we need to get rid of that. That means divide both sides by the same term, MA plus MB. MA plus MB. So cancel that, same thing on the top and bottom. So that means we have A given by minus mu K MA plus MB times G over MA plus MB. So everything on the right side is known, the values are given. Okay, so that means we can find acceleration. So let's plug in the numbers. So minus mu is 0.4, mass A is 10, plus mass B is 25, okay, and G is 9.8, over sum of the two masses. Okay, sum of the two masses is 10 plus 25. So do the math, you get the acceleration. Can you guys do that? So minus 4 plus 25, 9.8 over 35. So 25 minus 4 is 21 times 9.8 over 35. What did you get? 5.88. Did you say 5? Yeah, okay, 5.88 meters per second squared. If you want to write the correct significant figures, so there is only one significant figure, so you can write this as 6 meters per second squared. Okay, we are almost out of time, so we'll continue this in the next class. If you guys have any question, ask me the question. Otherwise, that's all for today. So let's see what's the question. What chapter of the book we are on in? Don't remember the chapter. So you will need to see the week 7 agenda. Okay, I haven't posted that yet. I will post that on Blackboard. So on Blackboard you will see the agenda for this week. On that agenda you will see which chapter we are on.